In this lesson, we will be adding and subtracting polynomials. The first thing we need to remember is how to combine like terms. Like terms are those that have exactly the same base and exactly the same exponent. And if you remember, when we have like terms, we will combine them together, adding or subtracting only the number out front or the leading coefficient. So let's do a little practicing. Let's take a look first for our largest exponent. So I have a negative 5x to the fourth, and I have a 9x to the fourth. If I combine, these would be like terms, and I would combine them together, simply adding or subtracting their leading coefficients. So this would be 9x to the fourth minus 5x to the fourth would be 4x to the fourth power. Next, let's find if we have any x cubed. We want to do these in order if at all possible. Here's a 4x cubed. I don't see any others, so that would be the only term that has a degree of 3. Now we want to take a look for our next largest. Our next largest exponent would be squared. So if I combine together the negative 3x squared and the 8x squared and the 6x squared, and I put all of those together. 8 plus 6 is 14, and then 14 minus 3 would be 11x squared. Our purpose in combining like terms is to be able to add or subtract polynomials. Let's take a look. I have a 7x and I have a negative 4x. If I combine those two together, since they are alike, that would be a positive 3x. And finally, I have my negative 19 and my positive 12 as my constant terms, and when I add those two together, because they are alike, I will get a negative 7. When I combine like terms, I am adding or subtracting only the leading coefficient. The base remains the same, and the bases must be exactly alike in order to add them together. Same variable, same exponent. Let's take a look at an example. If I want to add these two polynomials together, the reason that they are in parentheses is so that they are simply grouping them as a polynomial. But because they are being added, in our head we can drop off the parentheses and add together what's alike. So I have a 2x squared and I have a 3x squared. These are like terms because they have the same base and exponent. So I will add their leading coefficients together. 2 plus 3 is 5, and keep the base the same. The next term is a negative 3x and a positive 2x. And when I add those two together, I will have a negative 1x. And finally, my constant terms. I have a positive 4 and a negative 3. And when I add those two together, I get a positive 1. Then I will ask, is this finished? Is it in standard form? Yes, because our largest exponent is first, down to none, and we cannot add anything else together. They are not like terms. Let's take a look at our next example. Again, because it is addition, we will ignore the parentheses and add the like terms together. So our largest exponent is to the third power. So when I add these two together, 2x cubed and 4x cubed, it will be 6x cubed. Now I'm going to look for an x squared. Since I only have one term that is x squared, I do not combine it with anything else, and that would be a negative 8x squared. The next term I'm looking for is my x to the first power, and that's a negative 2x. That is the only term to the first power, so I do not combine it with anything else. Lastly, I have 8 minus 7. 8 minus 7 would be 1. this is my polynomial, which has been added. It is in standard form, and there is nothing else that I can combine together. If we take a look at another example, we now want to find the difference, which is subtraction. So now the important piece is that I am going to subtract everything that is in the second set of parentheses. To make this much easier, what we're going to do is simply distribute the negative sign to each of the terms inside the parentheses, and when I do that, it becomes a plus. So first we change that to plus, and then we distribute that negative sign to each of the terms inside the second set of parentheses. Now this example will be exactly the same as the previous slide. The first thing we'll do is find our largest exponent, which is to the third power, and I want to add those two terms together. 7x cubed minus 1x cubed would be 6x cubed. Next I look for my x squareds. I have a negative 4x squared. It is the only term, so I do not need to combine that with anything else. Next, I have a negative 3x. It is the only term to the first power, so I do not need to combine that one. And lastly, my constant terms, 1 plus 2 would be 3. My polynomial is now written in standard form. I have found the difference, which is subtraction, and I do not have anything else to combine. Example B is also subtraction. So the first thing we want to do is we want to change this to plus, a negative, which is distributed to each of the terms. Now I will combine like terms together. I have a 4x cubed and I have a negative 5x cubed. 4 minus 5 would be negative 1, and we don't have to write the 1, but we can, x cubed. Next, I look for my x squareds. I have one term that's x squared, so that will be plus 6x squared. I look for my single linear term to the first power, and that's going to be a negative 8x. Since there isn't anything to combine with that, I will write that one down. And then I have 9 and a negative 2, which gives me 7. This is my polynomial that I've found the difference, and it's written in standard form with no other terms to combine. One helpful hint, remember the reason I am changing the minus to a plus and a negative is this. When you take 2 minus 7, remember that's the same thing as 2 plus a negative 7, and that is why we are changing our subtraction to plus a negative and then distributing the negative sign. Remember that we will also be using function notation with polynomials, and we've talked about that earlier in the year. Function notation is simply used to identify functions, and it means the same thing as y. So, if I have my function, which is 2x squared minus 8x plus 3, and my function of gx is 10x minus 6, I want to add the two together. So all I want to do is take 2x squared minus 8x plus 3, and I want to add to that my 10x minus 6. It's exactly what we've been doing in our previous slides, but it's different vocabulary. First, I'm going to find my largest exponent, which is 2x squared, and there are no others to combine with that. Then my x to the first power, I'm going to combine those together. Negative 8x plus 10x would be 2x. Then my constant terms, I have 3 and negative 6, which is negative 3. I have added my two polynomials together and have written my sum, my final answer, in standard form. Next, I want to take g of x minus f of x. So my g of x is 10x minus 6, and I want to subtract my f of x. F of x is 2x squared minus 8x plus 3. Remember, with subtraction, we are going to change our subtraction to addition, and distribute that negative sign to each of the terms behind it. We are going to combine like terms. First, I have my negative 2x squared, and I don't have anything to combine with that, so that is my first term when I'm writing my polynomial in standard form. Next, I have my 10x, and I have a positive 8x. When I combine those two together, I have 18x. And lastly, I have negative 6 and a negative 3, which gives me negative 9. When I have now subtracted my two polynomials, I have combined like terms, written my final answer in standard form. When you are adding or subtracting polynomials, the first thing to remember is that if our polynomials are in function form, it's the same as what we've been working on, just different vocabulary. When you are subtracting polynomials, be sure to distribute that negative sign. And then we are going to combine like terms, which is to add them together. When we have like terms, make sure to remember that with like terms have the same base and exponent, and we are adding or subtracting the coefficients. Make sure you keep the base. Continue to work on your vocabulary and remember to complete the reflection.